Hi guys, another video again. This time a little power electronics, not much. Well, the reason I'm making this video is not only about this item that you see here on the cam, but I want to use this little thing for a bigger project, a larger project. Anyway, let's start with what we are seeing here. This is something that exists quite a long time. It is a small but really interesting and feature-packed mini electronic load. It's called XY-FZ35. There is a 25 version too, FZ25. The difference is that the 25 is only 25 watts, can burn only 25 watts. And this one that you see here, the 35, is the bigger one in the bigger one here for 35 watts. The design is more or less the same, yeah. Just the software is different from what I saw. Anyway, the data of this mini load are up to 35 volts of input voltage, VCC, to power this device, and up to 25 volts and 5 amps for the load voltage and current capacity. Total dissipation is 35 watts. This thing is interesting for me for a specific reason. I have this quite a while now and I didn't use it, only just for small testings and to play with it. My plan is for a future device, for a future design, is to make a low power multi-load, isolated. That means I plan to make a multiple input, it's an input load for up to that what it is, this one, 35 watts each, but completely isolated between all the 6 loads inputs. This thing is just for me to test, let's make it a little bit like that, to test multiple output isolated converters, low power isolated converters. First I thought, yeah, I will design it from scratch completely. And I said, yeah, I saw this thing on AliExpress, I ordered one and I tested it, and honestly I like it. It has so many features that I'm not even interested in these features. And it is quite okay. It's not the most accurate, but it's okay. Yeah, they do not use any ducts to control the output current. They use PWM and the low pass filter after that, but it's okay. Anyway, for this kind of testing that I needed, it's okay. It should not be a precision multi input load. Yeah, it should have the precision or that this one, the FZ35, delivers is adequate. Anyway, I took it. It looks okay. And from what it seems, I will use this FZ35 6 times, and I will just add an specially isolated DC-DC converter and some other functionalities to make this thing the multi-load I want. So that was reason enough for me to take it out of the box, make a complete test, to show you a test, a complete tear down, really a tear down, and to make a reverse engineering schematic of the complete power section. You will see it later, how it is. It's in two parts. So this is what I plan with this video, but for the beginning, let's see how it works. So, just as a little test, I will not show all the functionalities. I will put a link in the description, and you can read what it's possible. Yeah, I know, this is full of dust, but I want the protection foil on it. I don't like the screen scratched. Anyway, first of all, a very nice crispy display. As you will see later, the display is not a TFT or a matrix display. We can see it a little bit here. It is a segment display. This thing is a custom-made display for this purpose. You can see the segments in the dark. I like this kind of displays, but the problem is they are custom-made. And they are not cheap if you don't go to, let's say, a few hundreds of that here. If you want to use it only for 6 or 10 pieces, yeah, probably a TFT display is much cheaper. But they built this thing in the thousands, in many thousands, so it is quite feasible to use such a kind of display. I really like it. It's very crisp, very clear, readable from many angles. Look at that. This is an extreme angle at the moment, yeah? Very nice readable. But bear in mind that it's not only the LCD display and it's directly driven from some serial input. No, this thing, let me stabilize it a little bit better for you to see it. Go a little bit nearer because I'm moving too much when I'm speaking. This thing needs a dedicated display driver, a segment display driver. And you will see in this, after on the Teardown, it's an Holtec 1621. Then that means that these are additional costs. So to get this display up and running, you need the display itself, customized, that is not cheap, in low quantities, and the display driver, the LCD driver, the segment driver itself. And the software is not the easiest one, yeah, because you have to drive each segment by itself. So anyway, that means that in the near future, I will not use this thing. I will stay on my TFT displays and that's it. So, but okay, anyway, I connected it like that. I said, whoa, better, much better. I set to 5.3 volts. Please bear in mind that this thing is not calibrated, needs calibration. So the output voltage and the real voltage would not be the same. Yeah, both of these things are not calibrated. Yeah, you see 530, 526, and this is not the loss on the cables because the load is not active at the moment. It's blinking. Activating the load with this button. We are on. You hear the fan. 1 amp. 135. So I don't want to check it at the moment. Probably it is, I don't know, 135, and it says 1 amp. I set it to 1 amp, and the problem is that this little load here doesn't have a read back of the actual current that is draining. It just relies on what you set with this rotary encoder. And if I turn it, goes up and down. But what you see is what you set, not the actual thing. The only parameter that is a read back is this voltage here. Anyway, it is okay, it works okay. We have at the moment, we're drawing 5 something. Well, let's make it 2 to make it easier to calculate. Let's make 10 watts. And there is no faster way to turn it on. Okay, now it says 2 amps. And we have here 2 amps something, yeah, 530 volts. And here it says 5 volts. So this now is a combination of the uncalibration of both parts, the inaccuracy of that too, and the drop on the lines on the cables you have here. But anyway, it's working. It started already the fan. It is more or less 10 watts. It's dissipating 10 watts. Yeah, it's getting warm. Yeah. But it's nice. So this thing is not a bad solution at all. Yeah. Anyway, if you use it for the 5 amps, that means the whole 35 watts, this small, let's turn it off because it's noisy. And this too. Bye-bye. This small, I think it's a 40 by 40. Yeah, it's a 40 by 40 fan. It's too small. You have a lot of functionalities. Oh my God, the wattage. Yeah, let's play a little bit with the wattage. On. Let's turn it on again. This is the only thing that I want to show you because it's funny. Not funny, I like it. This is how it did. It calculates the watt, that's all, yeah. And what else do we have? How to set all the other parameters, I don't know. I have to read the manual, and to be honest, it has over voltage, over current, etc. Interesting thing is how it calculates the overcurrent. It doesn't how to measure the overcurrent. It doesn't measure it at all. Yeah, you will see in the schematics after that that I'm showing to you. The only parameter that is read back is the voltage, the load voltage, nothing else. This thing doesn't know what exactly, how much current in reality it is sinking. Yeah. It just has the set value and that's it. And this is how it calculates. It calculates only with the set value. Anyway, what do you think about that? Many things will come. Here is the schematic, what I want to show you, etc. So, if you like it, if you like my videos, if you like the content what I'm showing to you, if you like my designs, there are many designs in the pipeline, many unusual designs. I plan even to make another series of videos that will be called probably the unknown. No, not the unknown, but I don't know, probably peculiar devices, peculiar parts, interesting parts, something like that, where I will show parts, electronic parts, components that you will not see every day. And most of you will not even know what it is, yeah? Because I didn't even myself didn't knew what this is. One of the next videos will be one of these parts, will be interesting, I hope. So, if you like what you see, if you like my content, give me a thumbs up, please, by pressing the like button. Please consider subscribing my channel. This will help my channel to grow and to helps me to be able to show you more interesting videos. And as I said, there are so many videos in the pipeline. But the thing is, these are complicated videos. These are design videos that I have to wait for the PCBs, I have to make tests, etc. before I show you the results here. And last thing, press the notification button in case you want to be informed when I have a new video. But enough the blah blah. Let me show you now how this thing looks without clothes. Ooh, completely teared down, and a schematic of the power and the analog circuit part. I did not reverse engineered the microcontroller and LCD driver part. This is absolutely uninteresting. This is a school book example, nothing else, yeah? But all the other things are quite interesting, you will see. So, let's go. Okay, this is how this thing, the load, the XY-FZ35 load, mini load, looks naked. Okay, not naked, dismantled. This is the internals. It's a 2 PCB design. The base PCB that contains all the digital stuff in microcontroller and the additional analog power PCB. Let's take it apart. Let's stay from the easiest one. To be honest, I really like these displays. I don't know if you can see, I cannot see any segments. I really like them, but the problem is that they are custom made. And seems that even that they are a lot more expensive to make it, considering that you need a Heatsink or a similar segment driver for that. In mass production, if you go of thousands of those, then I'm sure that they are much cheaper than to use a I2C or a SPI TFT display of this size. But only on larger quantities. That's the bad thing. I really like it. There's a crisp display, nicely viewable in most of the angles. You saw it before, yeah. Yeah, then we have the clickety-click, the encoder, and one button. And on the back, we have the microcontroller, the Nuvoton, the Heatsink itself, the LCD segment driver, the 5-volt back regulator. This back regulator is used only for the fan and for the backlight of the display. And then you have an LDO that is used to produce the 3.3 volt for these two chips here. This is more or less what's on the on the digital PCB. It's not badly made, it's really nice, and for the money you pay, I don't know, $15 shipped or something like that, yeah, it's nothing, yeah. Now we have the power PCB. Let's bring it a little bit nearer. Yeah, what I forget to say is you can control this thing through a serial board, TTL serial. Even that is provided. There is no connector for that, but it's easily soldered. You have a heatsink and then small, quite loud fan, and on the other side you have the whole working part. And if we start from left to right again, we have, one moment please, to take my pointer. SS34, that's a polarity protection. This is the input, the working voltage input that supplies the electronics. Schottky diode for a reverse voltage protection. The switch MOSFET for the fan. LDO, 5-volt LDO for the electronics here that are used for the load, and this one, this 5-volt LDO supports. On this 5-volt LDO, you have another 3.3-volt LDO cascaded. This one, this one, that is supplying these two digital chips. There is not much to say here. The rest you will see on the schematic. I mean, I completely reversed engineered, of course, this part, all the analog part here, and all the analog part here. I didn't reverse engineered this part because this is not interesting. This is straightforward. Yeah. We have op amps. The op amps used are is a 4 op amp package, the LM324. They're using as a power device a Darlington, a tip 122. Interesting, yeah. Here you have the 20 milliohm shunt resistor. You have two SS54 5 amps each, Schottky diodes in parallel. These are used for polarity protection of the load input again. We have two missing diodes. Probably they thought, okay, either we put those ones or those ones. If you use those ones and you make a polarity protection, you have a massive short here on the load, yeah. And probably these two will be bye-bye. Anyway, this is how it looks. It is nicely made. It's a very nice idea. Honestly, I copied this idea of this form factor and the sandwich design. I will show it in another video. And let's take a look of the schematic. So here we have from left to right, again, the 5-volt LDO. Let me show it. It's easier if I show it in parallel. I should have taken down these cables, but okay, anyway, I was too lazy. That's this LDO. This is this part here. Yeah. The MOSFET. What I forget to show you is that this thing has a temperature sensor too, with an NTC, 10K NTC, and this is this part here. That's the NTC. Not bad at all for such a small and cheap device, yeah. And then we have the whole load part. Input of the power load here. This is why I made this lines thicker. Here you see where and how the current comes in. We have a voltage divider that goes to some ADC pin of the processor, and this monitors the input voltage. With that, they can see control the maximum input voltage and the wattage, how much watt we already are burning. Here you have a standard configuration of a low side load, electronic load with an op-amp. They use the set voltage for the output current. They use, of course, PWM. You have two low-pass filters back to back that makes from the PWM a voltage. Not very accurate, but more than enough for that what you pay. Buffer amplifier, just not to load this section too much, and a 18:1 divider that goes directly to the positive input of the load part. Because of this mini load has quite a lot of modes, one of them, or a lot of settings, one of them is the overvoltage protection. And this overvoltage protection is done by utilizing this part of the LM324 as a comparator. You have on the positive input of the comparator, you have the output of this voltage divider that monitors the input voltage. And on the negative side, you have the output of this buffer and of the PWM to voltage converter here that is set from some PWM chip from the Nuvoton that sets the maximum allowable input voltage. That means that if the input voltage here from this divider goes higher than the set voltage, this MOSFET switches to ground and grounds the input of the set current of the load. That's it. The capacitor is just nothing else to make it a little bit more stable and reduce the high frequency gain, so you don't have too many oscillations. So this is more or less the whole electronic load. It's not bad. There are shortcomings, but the thing is, what I miss here is they're nowhere monitoring the actual current that is the power part is drawing. They're relying on what they set, and all the calculations are done only by the set current, not by the actual current. There is nothing that goes back to the microcontroller. Yeah, this is how this thing works, more or less. Yeah. Well, let's take a look on the datasheets. So let's take a look on the datasheets. The first one is the microcontroller itself. It's a Nuvoton brand N76E003 series. It's a standard 8-bit 8051 compatible MCU. It seems that these are one of the cheapest because they were used everywhere in the Chinese equipment. You see them almost everywhere in the last years. And it's not that bad, to be honest. Yeah? It has a lot of peripherals inside that makes it quite interesting. You have a SPI serial interface, I2C serial interface, two UARTs, dedicated ones. It's not bad at all, yeah. A lot of PWM outputs, 10 external inputs, pin interrupts, 8 of them. This is more than you have on the Atmega. Yeah, quite a lot of IOs, general purpose IOs. And one of the most interesting features of this chip is that it has an 8 and 12-bit ADC. And this thing is multiplexed, the input of this ADC is multiplexed to 8 inputs, analog 0 to 7. Otherwise, it is very poor on RAM. You have only 256 bytes of internal RAM and additional 768 of auxiliary RAM, whatever that means, yeah. Nevertheless, both of that is not even, the sum of that is not even 1K. And then you have 18K of flash for the program memory and 4K that can be used for the bootloader. Yeah. Nice micro, but nothing really special. Let's continue to the LCD segment driver. There's an architecture of 32x4. It's from Holtec. It's an HT1621. This thing is used to control the segment-driven LCD. It's quite a beast compared to the SSOP 20 Nuvoton microcontroller. This thing is a SSOP 48. Of course, it has a lot of pins because, yeah, you need that for this architecture here, for the amount of segments that you can drive. Otherwise, serial controlled, nothing really special to say. Then we have from MST, Milestone Semiconductor, two LDO controllers, low dropout regulators. The only interesting thing on these regulators is that they have a quite high input voltage of 35 volts and quite good current capability of output current capability of 200 milliamps. There are two of them used, one for the 5 volts. The 5 volts are used for the analog part of or let's say the power part of the load, and the 3.3 volts that are used for the microcontroller itself from the LCD segment driver. And last but not least, for me the more interesting chip, it is a buck converter that can provide up to 2 amps, and the interesting thing is that it is quite high input voltage, up to 40 volts. They use the fixed configuration of this buck converter for 5 volts, like that here, and it's used for to provide the 5 volts for the fan and for the backlight display, the LED of the backlight display. Yeah, that's all at the moment from the data sheets. All the other chips and transistors are trivial, nothing really interesting. Well, that's for today. That's what I wanted to show you with a little bit of a test of this little mini load that I really like. The only thing that I don't like, to be honest, is that the load voltage is only 25 volts allowed. This is a software issue. I would like it much more to be 30 or 35 volts. Yeah, it would be much more versatile than only with 25 volts. But anyway, this thing will be used for the larger project that I told you, the multi-input low-power load. So, thank you for watching. I hope you liked it. Stay safe, my friends. See you next time. Cheers. Bye.